Here comes my next question. What skills should people have on their resume to stand out for machine learning positions?
Sure. So if we're specifically talking about machine learning engineers, I think that one thing to definitely think about is that just having the basic skill set of what a software engineer consists of is really important. So, the name says it itself. You are an engineer and you do have to know, your data structures and algorithms and just how to build software in general. But specifically on the machine learning side, this definitely varies depending on the type of roles that you're interested in. So if you're interested in, let's say, learning, or if you're interested in a role that might be dealing with computer vision tasks, then you'll want to know about, convolutional neural networks and other techniques for actually doing computer vision. And if you want to work with, let's say, text data, then you should know about, recurrent neural networks and also convolutional neural networks in this case. Another thing too is that you definitely want to be familiar with a lot of the popular libraries and frameworks for doing machine learning. So one of the ways to do that would be to get started with something like, let's say, TensorFlow or PyTorch. And being able to show that you are proficient in that, it's definitely very good to have. There's other machine learning libraries as well. So I specifically have used a lot of Python, so I'm very familiar with the Python ecosystem. And if you want to get into machine learning also, I do recommend that you learn Python. You can do it with Java, you can do it with R, but I think that Python is definitely the most popular nowadays. And so if you're just interested in breaking into the field as quickly as possible, definitely having that experience building software in Python and then learning Python packages, as I mentioned, TensorFlow and PyTorch are two good options. Keras is another one, scikit-learn. And yeah, just having experience there. And the best way to really get that experience, if you're just new to the field, is really to either take a class. There's a tremendous amount of really solid machine learning courses online. Specifically, I highly, highly, highly recommend Andrew Ng's courses, machine learning and deep learning courses on Coursera.org. I think are really, really good to take a look at. But also build some small toy projects. It doesn't have to be anything that's it doesn't have to be anything novel. It can just be you reading, let's say, a scientific paper and just copying the model there, or even just working on one of these models in one of your classes and just being able to explain it and articulate what you did and why you did the things that you did, and being able to just talk a little bit about those on your resume. You don't want to go too far into it on the resume. You definitely want to save that for the interview itself. But just actually having that experience of going out and building models and just being able to articulate that a little bit on your resume will definitely help you stand out.
Brad, what are the common questions asked in an interview for machine learning job?
So I think that this varies a lot based on someone's experience, but there are some things that I would say that anyone should know, whether you're a junior engineer or senior engineer. So just to list off a couple of common ones, I think a good one to know is the difference between supervised learning and unsupervised learning, and being able to explain when you might use a supervised learning algorithm versus an unsupervised learning algorithm. And just to give you a little bit of an understanding what those two are, I mentioned this earlier, or I started to mention this earlier a little bit, but supervised learning is the branch of machine learning that deals with training on data that is labeled. So for instance, I was using the Apple example earlier. So a supervised learning example might be learn that this is an apple, given that I'm telling you that it's an apple, so that when I in the future provide you with another picture that's not an apple, you will know that it's not an apple. And then unsupervised learning is training on data that is actually not labeled altogether. And that a lot of times comes in the form of clustering algorithms. But that's definitely something to know. And I think I'll leave it to all y'all in the audience to, I guess, take that up for yourself. A couple other things that I think show up a lot are in terms of case studies. So given that let's say you might be asked I want to build something that does, I want to build an algorithm that can detect the difference between an apple, or I want to build a model that can tell the difference between an apple and an orange. So what might be some algorithms that you suggest doing? What are the trade-offs of doing that algorithm versus another algorithm? And just being able to explain and defend yourself, I think is really important. Another good question is model accuracy let's say, is model accuracy the best metric for testing model performance? And I think your answer to that question is very indicative. The correct answer is no. It absolutely does depend. And again, I'll leave it to y'all to go and look at that yourself and see if you can figure out why that is the case. Some other questions include what is the bias variance trade-off and understanding what it means to have an overfit model versus an underfit model. Another one is, let's say there's two algorithms, machine learning algorithms out there called K nearest neighbors and K means clustering. And though they have similar sounding names, they're actually very different, but they are often confused. So knowing the difference between those two is important. Another question might be to derive a simple algorithm from scratch and explain the mathematics behind it. And just, and being a machine learning engineer, there is definitely some mathematics that you need to know, specifically linear algebra, some statistics, and some calculus. And a lot of that can be done, or a lot of that can be shown by being able to derive an algorithm. Yeah, I mean, there is a lot of overlap between what you might expect from a traditional data science interview as well as a traditional machine learning interview. As I mentioned earlier, you are an engineer and you still need to know about your data structures and algorithms, and you need to know the difference between, let's say breadth first search and depth first search of a binary search tree, and something like, or let's say graph algorithms and sorting algorithms and array algorithms. You still need to know all of that. So in that sense, it does make a machine learning engineer someone who really knows a lot of different things, which is cool from a learning standpoint, but also something that you need to make sure that you walk into the interview being able to answer, because all of that is fair game and all of that can come up on the job. And just making sure that you're prepared is something that's really important going into the interview.
Wow. So the next question is, what are the best resources to prepare for machine learning engineer interview?
Sure. So I think one fairly straightforward way to do it is to just go online and look up, just do, let's say a search on Google for what are common questions for a machine learning interview. And I think there's no shortage of resources out there. To just name a couple specifically, for the software engineering part of the interview, I can recommend no better resource than Cracking the Coding Interview. It's about probably $20, $25 on Amazon, and that has helped me out through numerous interviews, just in terms of the baselines of software engineering. So again, those the graph and tree algorithms and the search and sort algorithms, those sorts of things. Cracking the Coding Interview, it is written in Java, but that doesn't really matter that much, because you should be able to understand it and be able to translate it into any other language that you use. Really useful resource. In terms of the machine learning side of things, so I think really reading any book on, honestly, just statistics is really helpful, especially some Statistics 101, and just really making sure that you understand the basics there. There's some introductory linear algebra books out there that are really good. And I also recommend taking those courses such as Andrew Ng's machine learning and deep learning courses, because a lot of the questions that you may be asked will come from there. So I'd say those are probably my best bet. Another suggestion that really worked for me and helped me do really well in a lot of my interviews is to actually find someone who is currently working or has recently worked in the field and actually have them interview you, preferably on a whiteboard, because that is how a lot of interviews are done nowadays. There are some that are also done remotely, so either one works. But really, yeah, finding someone that has a track record for knowing what they're talking about and being able to ask you questions in a safe environment where they can help steer you in the right direction if you're, maybe perhaps just not answering correctly, or if they can provide more feedback to you in terms of how you answer the question. I think that is honestly the best way to do it, but I would not suggest starting with that. I would definitely suggest going through Cracking the Coding Interview and reading those linear algebra and statistics books before you move on to having someone interview you. But I do think that should be a really good, end goal before actually going to interviews.